Here is a short video on plotting fractions on a number line. This has a kind of confusing explanation in ALEKS, and so I wanted to make sure I talk through it and help you understand what's actually going on. So for this first example, we have plot 5/6 and 1 1/3 on the number line below. Our first step is to check and see how many of these chunks there are between 0 and 1. And the reason why is because a fraction represents a part of a whole. And so if my whole from 0 to 1 is cut into a certain number of pieces, that's going to be represented by a denominator. How many pieces is the total cut into? So I count, how many chunks are there? 1, 2, 3, 4, 5, 6. So there's 6 pieces. So that means my denominator needs to be 6. Okay? Which is great news for this one. Not so great news for this one, because this one, 5/6, is already cut into 6 pieces based on the denominator, but this 1 1/3 is cut into thirds, which does not match our number line. That means it's going to require some extra work. But before we begin there, we can actually take that first fraction and plot it. So it's the pure fraction, a proper fraction, 5/6, which means it lives between 0 and 1. You could think of it as being 0 and 5/6. We don't write that, but that's essentially what it means. So we start at the 0 and we go over 5/6. 1, 2, 3, 4, 5, 6. So 1, 6, 2, 6, 3, 6, 4, 6. This is 5, 6. So this is where we place our point. Now, if you go one more, you get 6, 6. And 6, 6 is the same thing as one whole. So hopefully that makes sense. Now, the second fraction, 1 1/3, has a denominator of 3, which is a problem because it doesn't match our number line. But remember, we can find an equivalent fraction to 1/3 that matches the number line by figuring out, well, what do I have to multiply the denominator by to get the 3 to match a 6? So what do I have to multiply 3 by and end up with a 6? That's going to be times 2. Whatever I do to the denominator, I must also do to the numerator. So therefore, 1 1/3 is equal to 1 2/6. So through this small step, we're then able to create a fraction that matches our number line. So that has a denominator that matches our number line. So now, because this is a mixed number and it starts with a 1, it's going to live in the space between 1 and 2, okay? And we go to the whole number 1, and then we go over 1/6, 2/6. So this spot right here is equal to 1 2/6, which we know is the same as 1 1/3. Okay, hopefully this helps. I have another example I can go through. Again, we're going to plot 2 1/8 and 1 1/4 on the number line below. My first job is to count how many of these chunks there are between 0 and 1. So 1, 2, 3, 4, 5, 6, 7, 8. Remember, that is to determine does our number line match our denominators, and if not, we need to do a little bit of extra work. So I look right up here and I see that 2 1/8 is already cut into 8 pieces. So this one is my happy fraction and my happy mixed number that I'm happy to plot. So I go over to 2 and then I move over 1/8. So this point right here is 2 1/8. Now, the second fraction, 1 1/4, does not match my number line because the denominator is different. It does not match how many pieces the whole numbers are cut up into. So we need a little bit of extra work here. I need to figure out how do I get this to be in terms of eighths. So I have to multiply 4 by 2 to have it match 8. So I have to multiply the numerator by the same number. So 1 and 1/4 is the same thing as 1 and 2/8. So this mixed number is going to live between 1 and 2. I go to the 1, okay, and then I move over 1/8, 2/8. Okay, so this point right here is going to be 1 and 2/8, which is the same thing as 1 and 1/4. All right, good luck. Thank you.